Okay, so let's go ahead and put that definition to work. So several videos there. Let's just, again, homework-like problems, if you would. So the first one, right, by the way, again, there's the definition, right? You're given a point x, y, and the terminal side. You find r by using the formula r equals x squared plus y squared. That gives you all the information you need to use the corresponding ratio for our angle. Right, and so first problem then, the point, we have a really wild point, the point square root of 3, comma 1, lies on the terminal side of the angle theta. So what does that tell me? It tells me that x is the square root of 3, which I think is about 1.7-ish, and y is equal to 1. So that's what we know, right? So you're basically given two of the three things that we need, right? The first thing is to draw the smallest positive angle standard position. So again, I'll come to my little grid. This is a quad 1, and so let me kind of go ahead and give it a little bit of tick marks here to give us some orientation. So the square root of 3 is roughly about 1.7, so it puts me about there. Y is equal to 1, so there's basically a picture, right, of our theta, right, in standard position, right? So there's basically our picture with that point, square root of 3, comma 1 on the terminal side. Right, and it happens to be the smallest positive angle. To get another positive angle, I would have to go coterminal and have 360. Sorry about that. Spit that out. Okay, and so now, right, to find the 6 trig function values, I know what x and y are. I just need to find r. So r, by definition, is my x value, which is the square root of 3 squared, plus my y value squared, and the square root of it. Well, the square root of 3 squared is 3. 1 squared is 1, so we're looking at the square root of 4, so 2. So in this case, r is equal to 2, and that pretty much takes care of everything, right? What does the sine of theta have to be for this picture, right? Well, it has to be my y-coordinate, 1, divided by my r-coordinate, which is 2, right? What's the cosine of this angle? Well, it would have to be the x-coordinate, square root of 3, divided by my r, which is 2, right? I'm just using the definitions and plugging in what I know, right? What's the tangent of this angle that we're looking at? Well, it's the y-coordinate, which is 1, over the x-coordinate, which is the square root of 3, all right? And don't forget here, we would have to rationalize our denominator, right? So we actually get the square root of 3 over 3. That's probably the way you're going to have to write your answer in my math lab, and it is the way I would like you guys to do it in the in homework and quizzes, all right? Always rationalize your denominator. So there's the first three. Of course, you could use the definition, or we can kind of see the fact that the cosecant is just basically the reciprocal of the sine, right? So we just flip it, 2 over 1, which is 2. The secant of that angle, right, would be 2 over the square root of 3. Of course, if I rationalize the denominator, we get 2 square roots of 3 all over 3 is our answer there, right? What about the cotangent of that angle? Well, it's basically my square root of 3 over 1, which is basically just the square root of 3. And so there you have it, all right? So again, a picture of what's going on. We're able to find r, and then once I have r, I basically have everything I need to define it. And one other thing I want to kind of mention at this point, I have no idea what the angle theta is. I have a picture of it, I can visualize it, I can see it, but we're not, at this stage in our course, I'm not really interested in what the angle is. I just know for this picture, for this point on this terminal side, for whatever that angle is, the output of sine is a half. The output of cosine is square root of 3 over 2. The output of tangent is the square root of 3 over 3, and so forth and so forth and so on. We'll actually talk about what that angle is later in the semester, but that's also something a little different for students because you're used to knowing what the input is and finding y, right? You're used to I'll give you x and you find y, or I give you y and you find x. Well, here I gave you the output and we still don't even know what the input is, right? And that's a little disconcerting for students, so get used to it. It happens a lot in trigonometry. All right, so moving forward, right? The next one, a very similar problem where our ordered pair is -1, 1. So here I know x is -1 and y is +1, right? I'm asked to again draw the smallest positive angle that represents that. So I'll just come over here and I have -1 and 1, so it's right there. So the angle involved, there's my initial side, and here's my terminal side. And so the angle involved would be that guy right there. So we're basically going through that rotation. All right, so there's a picture of the angle. I can see the angle. I have a terminal point on the angle. Again, anyone would do. There's actually infinite, but we're ready to go. So first thing again is to find our r. So negative 1 squared plus 1 squared. I think this is 1 plus 1. We get that r is the square root of 2. All right, so now I know that r, what that value is. So I can go to my definition and just start plugging things in. So for this picture, what is the sine of the angle that I have? What's the y coordinate? 1 over the r coordinate. Of course, if we rationalize the denominator, we get the square root of 2 over 2. Right? What's the cosine of this angle that we have? What's the x coordinate? Negative 1, right, over the r value, which is the square root of 2. So again, rationalizing the denominator, we get negative square roots of 2 over 2. What's the tangent? Right? Well, the tangent is the y value, 1 over the x value, negative 1, and we get negative 1. So there you have it. Again, I don't really know what that angle is. As far as this question is concerned, I don't really care. I just want to know what the outputs are, right? What are the 6 trig function values for the input of that angle theta, whatever it may be. And so there would be. Of course, again, cosecant would be the r value, square root of 2 over the y value, so that's just the square root of 2. The secant would be the r value over the x value, which is negative square root of 2. And the cotangent, if we flip those, we still get negative 1. And so there's basically all your trig values. All right? If you guys don't mind, just to save some space and some time, I'm already at 6 minutes. I'm asking for the 6 trig functions, but I'm just going to do the top 3. All right? So just be aware of that. I'm pretty sure, I'm hopeful, confident that you guys can fill in the details. So the next one, we have 1, negative 2. So x is 1 and y is negative 2. Drawing a picture of the smallest angle. Right, so my data point, we're at 1 and negative 2. So my picture, my initial side's here. I'm going to rotate to my terminal side about there. So there's theta and the point 1, negative 2 on that terminal side. So I have something basically in quad 4. All right, and so what's my r value? My r value is my x squared and my y squared square root of it. So I think we get 1 plus 4. R is equal to the square root of 5. And so now I have everything I need. So what is the sine of this angle that we drew? Well, it's the y coordinate 2, or negative 2, excuse me, over the r value of the square root of 5. Rationalizing the denominator, right, we get negative 2 square roots of 5 all over 5. Let me write that a little nicer. Negative 2 square roots of 5 all over 5. So there's our sine value. What about our cosine value? Well, by definition, it's the x coordinate 1 over the r value square root of 5. And again, if I rationalize the denominator, we get the square root of 5 all over 5. Right? Last but not least, what's the tangent of that angle? Right? Well, by definition, it's the y coordinate negative 2 over the x coordinate, which is 1, and we get negative 2. Right? The other 3, you just basically take the reciprocals or follow their definition. All right? But there's basically the 3 main ones. And again, the idea is if we have a coordinate pair on the terminal side, I can draw a picture of the situation. I can find the r value of the situation using my definition, and then I just plug it in. All right? So last but not least, I think that point actually falls within quad. Let me just stick to the chase. That falls in quad number 3. The x coordinate is again about negative 1.7, so about here, and the y coordinate is negative 1. So there's my terminal side with negative square root of 3 and 1. Here's my initial side, so we're going through this rotation right there, and there's my theta. So there's my picture of the situation given in problem number 4. Of course, now I got to find my r. It's negative square root of 3 squared plus negative 1 squared square root. If I square a negative, it's a positive, and we get 3 there. Square root of 3 squared. Square root of 3 squared is 3, and then plus 1. And so we get 4, we get 2 again. So r is equal to 2. So we're good to go, right? So what is the sine of this angle that I have drawn here? It's the y coordinate, negative 1, all over the r coordinate, which is 2. Right? What's the cosine of that angle that I drew? Well, it's the it's the x coordinate, negative square root of 3, all over the r value, that's 2. What's the tangent of that angle that we have drawn? What's the y coordinate, negative 1, divided by the x coordinate, right, negative square root of 3. And again, if we rationalize our denominator and use the fact that a negative divided by a negative is a positive, right, what we get is the square root of 3 over 3 for that. So there's our tangent value. And of course, how do you find the other 3? You either consider these guys as reciprocals, or you just use the definition and you keep on going. So there's our definition in use, along with the pictures. Hopefully that supports the groundwork that we did in the first part of this module. All right, the next one, we're already a little lengthy here. We're already 10 minutes, almost 11 minutes of this. I'll stop there and I'll do the next section, all right, in another video.